here. It says if you pull 2 marbles, and again, 1 at a time implies that this is simple probability. Okay, we want the probability of 2 pink. So we want a pink each time, and then the other key piece of information without replacement. Okay, so without replacement this time. So again, if I look here, the probability of pulling a pink marble, since it's simple probability, I go right to the fractions. Probability of pink, there's 11 pink marbles out of 25 marbles total. All right, but without replacement means I'm going to assume that I reached in, pulled out a pink marble, and I don't put it back. So now I've pulled out 1 pink marble. That means there's only 10 pink marbles left for my second draw, and there's only 24 marbles total when I go to pull the second marble. Okay, it's still and. The and is implied. I want a pink marble and then another pink marble. Okay, so and means we multiply. So now let's reduce this thing a little bit. I can cross reduce the 10 and the 25 are each divisible by 5, so that goes to a 2 and a 5. Then I can reduce this a little bit more. The 2 and the 24 reduce to a 1 and a 12. And now if I multiply straight across, that's going to give me an 11 over 60. And that's if I look at the next one, it says if you pull 1 marble, and right here, am I pulling one thing at a time? Yeah, I'm only pulling 1 marble. So again, it's revealing to me that this is simple probability. So if I'm only pulling 1 marble, I want the probability of 1 yellow or 1 green. So the probability of yellow would be 5 out of 25. The probability of green would be 9 out of 25. The word or here means we add. I already have common denominators, so I add straight across here. 5 plus 9 is a 14. Denominator stays the same. All right? And it doesn't look like that one's going to reduce at all. If I take a look at the next one, it says there are 4 vanilla and 12 chocolate cups of pudding. If 4 are selected at random, what is the probability of getting at least 3 vanilla puddings? Okay? And with this one, if we're looking at this thinking, okay, well, does it say that I'm doing one thing at a time? No, it doesn't mention that. It doesn't imply it in any way. So I have to assume that all 4 of these guys right here, all 4 of these are being pulled at once. Okay? So now it's no longer simple probability because I'm not doing one thing at a time. All right? So since it says at least 3 vanilla puddings, that means I could have 3 vanilla puddings and 1 chocolate pudding. Or I could have 4 vanilla puddings with no chocolate puddings. Okay, and since this is complex probability, I'm going to have to do a combination for each of these. So for 3 vanillas, if I were to look at 3 vanillas, that's going to be the combination of, there are 4 vanilla cups, and I want to pick 3 of them. And then for 1 chocolate is 3 vanilla and 1 chocolate, so I multiply. There are 12 chocolate cups of pudding, and I want 1 of them, so it's 12, choose 1. Or, the word or means I add, and now for 4 vanilla cups, that's the combination of, let's see, there's 4 vanillas, and I want to choose 4 of them. Okay, so now I have a couple combinations to do. This gives me a 4, this gives me a 12, and this gives me a 1. Again, the and that's implied there means I multiply, the or means I add, and when I add these all up, it gives me a 49. Okay, I'm not done yet. I still have to do the total number of options. And the total number of options is also going to require a combination. It's the combination of, well, if there's 4 vanillas and 12 chocolate, means I have a total of 16 pudding cups. And I'm picking a total of 4 of them, so I have to do the combination of 16 choose 4. And when I do 16 choose 4, looks like it gives me 1,820. So now this is the number of ways it can happen. This is the total number of options. So my probability is going to be the 49 over that guy. And of course I have to check to see if I can reduce this thing. So it's 7 over 260. And that's it. Okay, but again, when it's a complex probability, we have to set a combination up for each situation that's happening. Follow our implied ands and ors, and then put it over the total. If we look at this guy, it says there are 1,300 students at Mr. Jansen's School of Hard Knocks. 750 students are taking math, as they should be. 350 students are taking English, and 250 students are taking both. If one student is selected at random, what is the probability that they are taking math or English? Okay, and again, the key here, if one student is selected. So how many things are happening at a time? One, because I'm only pulling one student. So that means this is simple probability. So I want the probability of math or English. The probability of math, there's 750 out of the 1,300. Or English, for English, there's 350 out of the 1,300. Or means I add, but this is a special or, okay? Unlike the marble example we did earlier, scrolling back up to number 20, this example up here, number 20, was mutually exclusive because the marbles were either yellow or green. They weren't yellow and green at the same time. Down here, this one is inclusive because there's not just math students and English students. There are students that are taking math and English, which means that those 250 kids were counted once right here in the 350, and they were also counted once here in the 250. So since this is inclusive, I have to subtract the overlap because I counted those 250 students twice, and I don't want to do that. I only want to count them once. Okay, so since I only want to count them once, it looks like that's going to be 850 over the 1,300. Now I can reduce this guy. Looks like they're each divisible by 10 for sure, and then from there we can go with 5, and let's reduce this thing. Looks like I get 17 over 26. And that's it. Okay, but when it's inclusive, we have to remember to subtract the overlap. All right? If I look at this one, it says I want to find the mean, variance, and standard deviation. Remember, for the mean, we just have to add all of our values together and divide by how many we have. So I'm going to add these all up and divide by how many I have, which is 1, 2, 3, 4, 5. Okay, the mean is the average. So let's add these together. 15 plus the 12 plus the 13 plus 13 plus 17 divided by 5. And it looks like I get a 14 for my mean. Okay, so the mean is 14. Now we have to go to variance. Variance we show as sigma squared. And remember, that's the formula where we do x1 minus x bar squared plus x2 minus x bar squared plus. And we keep doing that until we've used all of our data values, and then we divide it by n. Okay? So for the variance, I'm going to start with my first value, which is the 15. I'm going to subtract the mean, which is 14, then I'm going to square it. Plus, I've got to do it with the next one. 12 minus the 14 squared. And each time I'm always using the mean. I'm subtracting the mean from it. 13 minus 14 squared. 13 minus 14 squared. And yeah, the 13 appears twice, so I've got to do it twice here. 17 minus 14 squared. And then I'm going to divide by how many values I have, which is 5. And now it's just time to simplify this. And most of this, we should be able to do this fairly easily. Here, 15 minus 14 is 1. 1 squared is 1. Hope I didn't lose anybody there. I was pretty tough. Okay, next one. 12 minus 14 is a negative 2. Negative 2 squared is still going to be a positive 4. Okay, and I'm just going to go down through. I'm going to do each of these. 13 minus 14, negative 1 squared is a positive 1. Next one is the exact same thing if we look. So that's also going to give us a positive 1. And then the last one, 17 minus 14, is going to give us a 3. 3 squared is 9. So that's a plus 9. And then divided by 5. Okay? So again, I've got to plug this into my calculator. 1 plus 4 plus... I guess I didn't really need to plug this into my calculator, did I? That was pretty easy. Anywho, we get 16 over 5, which we just... we don't need to round this one off because it only had one decimal, but 3.2. And that's our variance, okay? So the variance is 3.2. And if I look at this guy, variance, remember, was sigma squared. Standard deviation is just sigma, okay? And remember, the only difference between standard variance and standard deviation is in this formula, we do the exact same thing. Squared plus 2 minus x bar squared plus, we do the same thing, we divide it by n, but then we take the square root. Okay, so do we need to plug this into another formula? No, we already knew all this stuff inside the parentheses. We already figured this out when we did the variance. So really all we're doing here for the standard deviation is we're taking the square root of the variance. And the variance was the 3.2. So I've just got to take the square root of that. And it gives me a 1.78854. And it keeps going. What did it tell me to round to here? Oh, it didn't tell me. We'll round to 2 decimal places, so I'll say 1.79. Okay? Variance and standard deviation. All right? For this last one, it asks us to use the calculator to calculate the mean, the variance, and the standard deviation. So again, I've got to get my calculator back out. Here it is. Now, when we do this on the calculator, remember we have to go to Stat. So I'm going to click on the Stat button, which is this one right here. You can see it right in the center. So I click on Stat, and then I choose the first option here. All right, Edit. And now I can punch in my list. If there's already things punched into my list, and I want to, of course, let me get back into my list here. If I wanted to clear my list, if I already had something there, I go up to the top, so L1 is highlighted. I hit clear, and you notice it clears it down here in this, where this blinking cursor is, but now I have to hit the down arrow. Once I go back down, it's cleared. Okay, so I'm going to punch each of my values in. I've got the 12, 14, 13, 15, next one is a 10, and then we've got a 16, 10, 20, 16, 18, 19, 16. Okay. If I look, I've got 12 things punched in here, and if I check my list, I've got 12 things over there. So now once I have this punched in, I'm going to go back to Stat. Again, remember Stat is this guy right here, so I hit the Stat button. I go over to Calculate, and since I only entered in one variable, I click on the very first thing here, the one variable statistics, because that's what it's calculating. I hit Enter, and now I've got to hit Enter one more time, and it gives me all the stats here. All right, and if we look, the very first thing listed is the X bar, and that X bar is our mean. So for the mean, I'm going to put down 14.92. I'll round it off. The standard deviation is the other thing that it gives us. If I look back over here, right here, there's sigma. All right, it says sigma x. That's our standard deviation. So for my standard deviation, I'm going to write down the I'm going to write the whole thing down for the time being. And the reason I'm going to do that is because now to go back from the to the previous problem, to get from variance to standard deviation, I took the square root. So since this time I have the variance, I want to go back to standard deviation. I've got to square this. Okay, so I'm going to punch that whole number into my calculator, the 3.1213868. Okay, I'm going to punch that whole thing in, and I'm going to square it just so I can have a little bit more accurate results, which means that my variance over here is going to be the 9.74, and now I can round it off. And when I enter my answers in over here, I don't need my calculator anymore. I'm going to put my rounded versions, the 14.92. The variance, I'm going to put the 9.74. And then the standard deviation, now that I've gotten my use out of keeping those decimals, I'm going to hack them off and say it's 3.12. Okay? And that's all there is to it. Plug it into the calculator, remember which buttons to push. All right? But again, to get a more accurate answer here, I kept all these decimals, then I rounded it at the end. All right? I hope this was helpful, and good luck on your test tomorrow.